I subscribe.
All right, welcome everybody. We are going to do multiplying rationals, okay? Now, you might think, holy moly, this looks way more complicated than it did before, right? The old questions just look like this, and we only had one thing to simplify, right? But now, we've got two things, and it's looking really crazy, right? You go down to number 11, and you think, wow, two things, and it's looking really, really insane, okay? Here's what I want you to kind of keep in mind, though, okay? When we have two fractions, let's just pick a number like 2/3 times something like maybe 6 over, pick a number, 10. So let's just say we have some number like this, okay? When it comes to multiplying these two things, multiplication of fractions just means you're going to multiply the top two together and the bottom two together, okay? And so that would just be 2 times 6 over 3 times 10. Now, if you look at it like this, this basically means we've got two things that are multiplied together, but they're not locked together, right? I could say that this 2 and this 10 can reduce each other, right? Because they're multiplied together. And I could say that this 2 is going to completely go away, and this 10 is going to have a 5 left behind, because that's, basically 2 times 5, and the 2 have canceled out. And I could also say, this 3 and this 6 could cancel out. Maybe I'll use a different color to make it clear. And that's going to have a 2 left over, because 6 is kind of like 3 times 2, and the 3 have canceled out. And so you could say that this is 2 over 5 as our answer, right? There's a 2 on top, there's a 5 on bottom. But notice over here, the 6 and the 3 that I canceled out were on opposite fractions. But we saw over here how that was totally okay. That's totally allowed to do. So what we're going to do is we're going to have a question that looks like this, okay? And the same exact process. We need to factor it, and then we need to cross stuff out. And even if we have this multiplication here, we're still going to be able to cross something out if it's on the opposite side of the multiplication sign here. Basically, the way I like to think of it is this is basically just one fraction anyways. Because all we need to do is multiply the top stuff by the top stuff and the bottom stuff by the bottom stuff. So when it comes to multiplication, you can solve them almost exactly the same way you solved the last questions, okay? It's just a little bit bigger, right? Now we have 1, 2, 3, 4 different things, but all the same rules apply. Multiplication, we're going to do factoring, and then crossing out. It's a lot more to factor, but that's it. So let's start by doing factoring, okay? We've got A, B, C, and D. We've got 4 different parts to factor. Let's start with A here first, right? Let's start with this one. How are we going to factor that? Can't be trinomials, can't be difference of squares because of this x, so it has to be GCF, and I agree we can take out a 4, so what else can we take out? An x, and what are we left over with? And a -1. Remember, if we take out 4x and the whole thing goes away, we need that placeholder 1. Don't forget that. That's a little GCF reminder coming back to haunt you a bit. Okay? Cool. I'll go ahead and do it like this. Where do you want to go next? Which corner you want to go to? Top right? Okay, top right. Sure. So now we'll go up here. We've got x squared plus x minus 6. That's a trinomial. First times last is -6. That's a minus and a plus. How are we going to make +1? Plus 3 minus 2. You guys cool with that? Okay. X plus 3, x minus 2. Now remember, when it comes to multiplication, all of these things, right? 1, 2, 3, 4, 5. These 5 things, they're basically all on the top, right? It's not really like we have a left and a right. We just kind of smashed them together because in order to multiply these things, we literally just put them next to each other, which is not hard. Okay, now we're going to go, where are we going next, Aiden? Bottom left, bottom right? Bottom left, okay. Bottom left is going to be the hardest of the bunch here because I've got a trinomial, but I've got this 2. That means I have to do the long way of factoring unless I can get rid of the 2. Can I get rid of the 2? Okay, so that's good. I'm going to go ahead and go down here and make sure I have enough room to do this, okay? 2x squared plus 4x minus 6. I agree. I can take out a 2. Now I've got a trinomial here, right? Let me not forget my 2, so I'm going to put my 2 up there. I've got this little trinomial here. I need to do 1 times negative 3, which is negative 3. How do I make a positive 2? Right. X minus 1, x plus 3. So, x minus 1, x plus 3. And if we look at the whole question now, right, let's not get ahead of ourselves, but it's starting to look kind of nice, right? We're starting to see some stuff on top, some stuff on bottom, starting to line up pretty good. One last piece here to handle, right? We've got this bottom right piece. Let's factor this. It's not difference of squares. It's not trinomial. It has to be GCF. What's the GCF? And what's left over? 2. Right, because 4 times 2 is 8. So, this is step 1, factoring. It was 4 factoring questions, but all we did was factoring, okay? So keep this in your mind. We've done nothing new so far. Not a single thing is new. Here's the new stuff. Fruit Ninja. What do you see that's in common? Somebody shout out something we can cross out. X plus 3, x plus 3. Can we really cross these out if they're on opposite sides? Yes. Yes, we can, because it might as well just be one fraction. X minus 1, x minus 1. Anything else? 4x and 4x. Anything else? Maurice is mad because Aiden's hogging all the work here. Anything else? I mean, I've got 2 and 2 and 2. I can't cross out any of that stuff? Right. I agree 100%, right? This is locked together. This is locked together. This is, has nothing to be locked to, so it's kind of by itself. None of these are matches. We cannot separate the x from the 2 because they're locked together. So we're done. We need to write our answer, and we need to make sure that we write it carefully. What is everything left over on the top? What is everything left over on the bottom? 2 and an x plus 2. Now, you never need to keep going. You never need to, unfactor stuff. We want to break it into all the parts and then cross out parts, and that's it. We don't ever need to multiply the parts back together. So we do not need to distribute the 2 here. We're done. This is beautiful. This is the perfect answer. Really good job. Really, really good job. Okay. Now, if we look at a question like number 12, we're not going to do this whole question, but let's just look at it really quick. I've got, A, B, C, D, 4 different parts. I need to factor all 4 parts, right? Let's start by just handling this top left part. Okay? What are we going to do with this top left part? Take out a 5, take out a V, and what's left over? 2 minus V, right? What are you thinking? Red flag, right? We've got a backwards subtraction point here, right? They're going to try to trick us. I can see it happening already, right? I know it's going to happen already. Whoever that evil math teacher is, they're trying to get us, dude. I'll give you a hint now. Okay, I'll just solve these really fast for you. If we do this top one over here, that's going to be v minus 9v plus 1. If we do this bottom left one, that's going to be v minus 9v minus 2. And if we do this bottom right one, we can't do anything. Okay? Now, lucky for me, I've already notified myself and said, whoa, 2 minus v. Look what we've got. A v minus 2. Do those things cancel out? Yes. But they don't cancel out completely. They're going to give us that negative 1 left over. Don't forget this. That's very important. What else cancels out? Right? What else? A v and a v, because it's not locked to anything. Right. The 5 and the 15, and what's left over from the 15? A 3, right? Because that's basically a 5 times 3, and the 5 is gone. So we need to figure out what is left over for our answer. Okay? On top, a negative 1, a v plus 1, and on bottom, 3. Beautiful. All right, really solid job. That is multiplying rationals. It's basically the same thing